treated the square as a rectangle. Yes? But we couldn't treat a rectangle as a square. Yes? So we saw where we can treat the child. Anytime you want to remember child, parent, just remember one go for square and rectangle. Yes? So generally now we can treat the child as a parent, but we cannot treat the parent as a child. So remember now too that we have animal. Let's say animal is a parent. We have mammal is a child. Yes? Every mammal is an animal. And everything that is in mammal, that is an animal, is in mammal. But not everything that is in mammal is in animal. Yes? Mammals feed their child milk. They suckle their young. You can't go and tell a fish to suckle its young. You can't tell a snake or an alligator to suckle its young. Yes? So you cannot treat the parent as a child. It's easy to remember when you do it like that. But you can treat the elephant or the cow as an animal because it is an animal. So you can treat the cow as a generic animal. You need to feed it, right? You need to give it water, it needs shelter, it will have babies, etc., etc. Same thing for dogs. Dogs are also mammals. Yes? Right? But you can't treat dogs like cows. You're not going to milk a dog and feed it to your child. You cannot treat one sibling like another sibling. Although they both have the same parent, you can't treat them like the same. Yes? And if you can't do it in real, you can't do it in the program, in your computer. And when you write programs, anything that is not allowed in real life will not be allowed on your system. Yeah? But here's the thing. The mammal has a child, like cows, is a child of mammal, right? Yeah? So you can treat the cow as a cow, you can treat it as a mammal, and you can treat it as an animal, depending on the circumstance. In some situation you care, it's very important that you treat it as a specific cow. You treat the dog as a specific dog. But there are other cases when you can treat it like a mammal, or you can just treat it like an animal, a living thing. You know, be nice to it, not cruel and all them kind of things. Right? So the cow can take many forms. It can take the form of, it's the form of a cow, that's what it is. That's its base class, that is where it was instantiated. It was created by another cow, by the cow class. Yeah? That's its base class. But it's also a mammal, so it can be treated as a mammal. It can take the form of a mammal, it can take the form of an animal. So a cow can be treated in three ways. That is polymorphism. Poly means many, like polygon. And morph means form. When you morph into something else, that's short for saying you transmorph. You change your form. Yeah? So morph is form. Polymorphism, polymorphology, all those things means that it can have many forms. I can have many forms and you can have many forms. Right? I am here, lecturer. There are times when I sit in a class. This August month I was sitting in a class taking lectures. Right? I was being trained as a lead auditor for ISO 2701. So in that class I'm a student. It's still me, but over there they're treating me as a student. It's how you're treated me. That changes the form that you are in. It's still you, but it changes the form. Right? So when I go home, I'm a husband, I'm a father, I'm a homeowner. To the bank, I'm a customer. Right? To UTT, I'm an employee, and I'm an employee. So I can have many forms depending on where I am. And they're all subclasses of the class person. Yeah? And I inherit everything as a person. So polymorphism is taking on many forms, and when you have polymorphism forms because of the hierarchy, parent, child class, child of child, subclass, that is polymorphism through inheritance. Good? You can have polymorphism as well in other forms. We will see that showing up a little bit, polymorphism through interfaces. Okay? Now, so let's take a look. We have 3 sets of presentations for inheritance. We're going to go through all of them. Why? Because every presentation focuses on something different, and you'll get the exposure to all of these. Good? Yeah? So it's going to be very boring if all in one go presentation. But all of it is supposed to be easy for you because we have done that already. With me? Let's see how that goes. And they are all written by different authors. Is there any benefit from that?
Different perspectives.
Different perspectives. It can confuse you as well because they all have different focus. Right? So when I'm talking, I have a different focus on what they have. So your focus will be what I emphasize. And if there's something I don't emphasize, it doesn't mean it's not important. It means it may not be important in this class, but the concept is important for you to know as a person who's going out there to work in that field. So you should always read more. Even if you say, well, okay, you said I ain't coming to the exam, I studied it. Remember, that's not the end of it. Right? During your holidays, August, Easter, Christmas, whenever, I would expect that you'll still take the books and read through it. I have all these books. I have all of them on soft copies, hard copies, and every so often I will pull up and I will read. I'm always getting refreshers, and every single time I teach a course, I learn something new. Remember, I told you I don't know everything. Right? You have some lecturers who know everything. I'm not one of them. Okay? The objectives of this chapter are to explore the concept and implications of inheritance. One of them is polymorphism. To define the syntax of inheritance in Java, you already know that. To understand the class hierarchy of Java, you already know that. To examine the effect of inheritance on constructors, you already know that. You might think you don't know it because you can't answer it if I ask you a question, but that's because you have not been reading and reviewing and practicing. Right? When you see it, you'll tell us something, so we didn't know that. So you never teach us that. Okay? That's fine. Inheritance is a fundamental object-oriented concept. That's why we do it in this course. Because this course is what? Object-oriented programming. Java is secondary. Java is the medium, not the objective. When you were doing last semester and the semester before, we did programming 1 and 2. Programming was the objective. C was the medium, it was secondary. Yeah? A class can be defined as a subclass of another class. The subclass inherits all data attributes of its superclass. The subclass inherits all methods of its superclass. The subclass inherits all associations of its superclass. Is there anything there you didn't hear before? Or you don't understand? See, I told you. Does that mean it's repetitive and you're about to pay attention? No. The subclass can add new functionality. If you're not adding new functionality, there's no point in having a subclass. Yes? Right? If you have cows and you're creating a hybrid cow, you are creating a new class. And you're going to give it a new name for that type of cow. That's how come they have effort, yeah, and a bunch of others, like the Longhorn and Zeeble and quite a number of others. if they were not different, if there wasn't something new about them, then there was no point in giving it a new name, because it's the same old thing you're calling it new. The people who manufacture cars, right? When they create a new model, they will give it a new model number. If they're not creating a new model, there's no point in having a new model number, right? Yeah? They might have different names, like the Sentra and the Sunny and the God knows what else. They're all the same vehicle. They just have different names because of geography, where they sell it. But they all have the same model number. So when they buy parts of that model regardless of the name of the vehicle. Yeah? They're not going to create a new model number if they're not creating a new class of vehicle. And that class of vehicle is going to fall under one of the existing classes. For example, the Hilux and the Fortuner were built on the same platform. They started off as one, and one went pickup and one went SUV. Same engine, same front, same doors, everything. Yeah, the only brake and suspension and everything in front is the same. Right? The Pathfinder and the Navara, same vehicle, same platform. See where I'm coming from? So they inherit stuff. But there are things that might be different. The things that are different is either new stuff or overridden from the parent. The subclass can also use inherited functionality. What's the point of inheriting all that thing up there if you can't use it? Yeah? These days, some of you might get some rules from your parents if you can't use it. So there's no point in inheriting it. Because they'll look bad if you sell it. Right? They say that's a betrayal, the parents give you it. You can't wear it because they'll beat you up and take it away. Always. Right? And you have it in the house as a security risk. See? So there's no point, isn't it? So if you can use it, then it makes sense inheriting it. But you could also override inherent functionality. You have that functionality, you just do it differently. Make sense? Is there anything on this slide you didn't know before? And we can have superclass like person and employee. You see, the employee has new stuff, has new characteristics or attributes, as well as functionality, because an employee can do something. And the person has name and date of birth, which will be inherited by employee. So employee has all of these things and all of these new things. And when we go to functionality, everything a person can do, an employee can do it too. Yeah? If you understood everything I said and everything on that slide, that means you have been learning. If it's all new to you, that means either you've been absent or you're not paying attention or you're not doing your work. Fair enough? I'll wait till you rise. So what really happens? When an object is created using the keyword new, the system must allocate enough memory to hold its instance variables. So it will allocate that space formatted for the variables depending on the different type. You know that when we talk about it? Yeah? I'm just saying that so you'll know that yes, we cover the material and yes, you're learning. And if you happen to miss stuff for one reason or the other, you will know that yeah, we did do that. This includes any inherited instance variables. In this example, we can say that an employee is a kind of person. So a cow is a kind of mammal and so on. An employee object inherits all of the attributes, methods, and associations of a person. What are the associations? That's like relationships with other classes and so on. Yeah? So in here now you see employee is a kind of person, and that arrow is a kind of, shows you that it inherits. So Sally is an employee. Sally Halls will have a name and a date of birth and then all of these things. Because employee inherits from person. This person is a different person. It's another instance. This person named John Smith, and his date of birth is January 13, 1954. This person has nothing to do with employee. Employee inherits a person. Doesn't mean person has anything to do with employee. You can have people who have no relationship with employees. Totally independent. But an employee cannot be independent of person. Inheritance in Java. It is declared using the extends keyword. In C++, we actually use is-up. But in Java, we use extends because what are you doing? You're literally extending the class. You're adding new attributes and new functionality, and you're changing things. You're putting new ways to do things. So here you have the public class person, private string name, date, the date of birth, and so on. Right? Date is a, notice the capital D. Date is an object. So this class person, an object person can have an object for date of birth. You can have an object for address. That's associations. Employee extends person, and we can see how we do it. And this is nothing new to you because you know that code. You can read that code and understand it, yes? Every word here, you know what it means and where it comes from. Right? You know which are keywords and which can be changed. And this here is the line that is used to create an employee object. What is the word we use when we create a new object? The constructor is what we use. But what is the word that says clearly that we are creating a new object?
New.
You'll laugh at yourself or not? Instantiate. And you hear that word before? So whenever you see this new, this keyword new in front of the constructor, you are instantiating a new or another instance of the object of that class. Yes? And this is the type. Class is a type. And this is just a variable name. It could be any name. And this is the constructor. Is there anything on any of these slides you would like explained? Please let me know. And if you do, you wouldn't be the only one. So you don't want to feel afraid to ask a question. So inheritance hierarchy, each Java class has one and only one superclass. That means that you can inherit only from one parent. We know that's not normal, and in the real world it doesn't work like that, but it simplifies the process. I will show you soon how we can get around that to bring in that concept of multiple parents. But we don't use inheritance.
Excuse me, sir. There's no cases of inheritance where it inherits from two different classes?
Not in Java.
Oh, but in other languages?
In C++, you can inherit from any number of parents.
Alright. So wait, in C++ isn't a limit to inheritance?
Not that I know of. I think it depends on the amount of memory your computer has. But your computer will try to do that, and if it doesn't have enough memory, it's going to give it trouble. So in C++ allows some, look, it's written there, C++ allows some multiple inheritance. Inheritance creates a class hierarchy. Remember the animal and the mammals and the reptiles and whatnot? And then each of these have their own children. You can see that happening here. So classes higher in the hierarchy are more general and more abstract. When we say animal, that's, remember I used the term generic, a more generic living thing. And down below you have cow. Cow is a very specific, mammal is a very specific kind of animal. cow is a very specific mammal. So the lower down you go, the more specific and concrete you get. The higher up you go is more general and abstract. In other words, there are some things that are not. Abstract simply means you leave out some details. So when we talk about something as an animal, I am thinking of an animal, right? All you know, well, it's alive, it makes children, it breeds, and it excretes, it takes in oxygen, gives out carbon dioxide, and all that kind of thing, right? That is more abstract because you can't think of a shape, you can't think whether it has fur or feathers or scales or whatever. You're just thinking of some living thing, and you don't have in your mind, you don't have any details without excuse. April of morning, sorry. Alright, but that class. Sure, no problem. Till he is with that lady. Yes. No, we got up Friday evening, I think, so I didn't get to talk to her. Right, so I thought you would have, right, so if you talk to her and tell her when we have this draft, it's a new draft, and if she wants any further information, she can talk to you, then you want to yeah? Yes, we did, that's right. Yeah. Sure, no problem. Yeah. Okay, bro. I'm sorry, I was. Thank you. No problem at all, no problem at all. Okay, so we continue in. So you realize what the purpose of this slide is now to consolidate all of the things I've been talking about for the last few weeks. In case people feel I was just all talking and ranting and wasn't doing anything concrete. Right? And what you'll find happening is that you are understanding what is on the slide, am I right? Because of the work that we have done. Had I come and sit down and read all these slides for you, you would have just be hearing a bunch of words that wouldn't have been very meaningful. Yeah? That is why I teach it the way I do it. So you get the concepts, get the ideas, and we consolidate it, then we can go and answer questions. So higher up the hierarchy, more abstract and vague. As you come down, it's more specific and concrete. There's no limit to the number of subclasses a class can have. There's no limit to the depth of the class tree, that is the hierarchy. Some can have many subclasses, many levels. Some can have many subclasses. Some can have no subclass. There's no rule that says a class has to have subclass. At the very top of the inheritance tree is a class called object. One of the very first things you heard me say in this class is that everything is a thing. Yes? What's another word for thing? Object. We had said that they are tangible objects and they are intangible objects. Yeah? A is tangible or intangible? It's tangible, otherwise you would have talked about it. Yes? It's there, it's real. You can't see it, you can't touch it. Yes? You can feel it when the breeze blows on your face. You can feel it when you inhale. If it's not there, trust me, you'll feel it. There are some things you appreciate more in its absence than in its presence because you can forget your breathing after a while. But the second you don't get it, you will feel it. Yes? You know they say you only miss it when it's gone? And things like intangible, things like love and a holiday, and that's intangible. What about a ticket? Is that tangible or intangible? When you buy a ticket for a trip,
That's happening.
you pay for a flight. What is important there? The ticket? Or the information it contains?
The information.
Because you don't have to have the ticket, you'll get on the flight without it. Right? You go there and you tell them who you are. And they take your passport and they'll pull up and they see you have stuff there. Right? Yeah. So, tangible versus intangible. Your name, is that tangible or intangible? It's intangible. Yeah, there you go. So, but it doesn't matter that some of them, even intangible, can be represented in your system as objects. Like a trip. You can book a trip. You can't hold a trip in your hand. What is a trip? It consists of things, right? A travel itinerary, a place to stay, things to do, access to shows and so on. Yep. Very different. And some of it is kind of hard to get your mind over. But after a while, doing this kind of work and thinking along those lines, things will fall into place. So at the very top of the inheritance tree is a class called object. That represents all things. Anything is an object. Tangible or intangible. All Java classes inherit from object. You know, once we say noun, we mean a thing or an object. So when we say, where's so and so on, you start with, that is a thing. You're obviously being, that's abstract, isn't it? A thing is very abstract. But as you put it in the form, it gets more and more details and concrete and specific. So we start off with our class called object and everything else inherits from that. But when, remember we said when you write a class, you don't have to say extends object. That is understood. Okay? All Java classes inherit from object. All objects have a common ancestor. This is different from C++. The object class is defined in the java.lang package. Examine it in the Java API section. Why show you how to get to the Java API section? Well, I don't remember that yet. You will find it in under Oracle. So the Java Platform API and so on here, Oracle. So you can look at if you do Java class objects. And you look here in Oracle. The class object. The constructor is here. These are all the methods. Remember we talked about float, equals, hash code. Remember we talked about those? I showed you how to write to string. We're going to do these soon. In fact, I did equals with you, sort of. To string. Then you also have get class. You can ask an object what class it is by using the method get class. So you have an object, you can find out what class it is. Clone will create and return a copy of an object. We talk about deep copy and shallow copy. Right? And then you can have other stuff. So this is where you can find out stuff about all the classes in Java and so on, like integer, sorry. All the wrapper classes. Speaking of which, we will do somewhere wrapper classes. And you see the string here. We don't do every single one of them, but you can read what you need to know. Okay? Then, we continue. Classes use constructors to initialize instance variables. When a subclass object is created, its constructor is called. It is the responsibility of the subclass constructor to invoke the appropriate superclass constructors as the parent, so that the instance variables defined in the superclass are properly initialized. Superclass constructors can be called using the super keyword in a manner similar to this. So you know about super that we use in the square class, as well as this. Remember this, right? The super must be the first line of code in the constructor. If a call to super is not made, the system will automatically attempt to invoke or call the no argument constructor of the superclass. Remember the no argument constructor? Remember every time we write a class, I tell you we should write a no argument constructor. That's the one with just the round brackets with nothing in it. What we call the default constructor. So here's an example of this one. Pay particular attention to this, please. Public class bank account. So a bank account has the owner's name, an account number, and a balance. Notice the account number is of type int. There's no fractions in that. And the balance is float because it has what? 2 decimal places. It could have been double. You could have used double. The constructor, the bank account constructor takes as arguments an account number and a name, and it creates a new bank account for that person. And see, the account number goes to account number, and the name goes to the owner's name. So when you create the bank account, you're creating it without a balance. In this case, can you open any bank account in Trinidad and Tobago without a balance? No, we have to put something in it. So there's what we call an opening balance. Right? Among your other stuff, this means and so on. Right? What's the name of this symbol? 3 dots. Anybody knows the name of that symbol? You know it means and so on, right? Yeah? Continuing like that. The name of it is ellipsis. E-L-L-I-P-S-I-S. Obviously, knowing the name is not important. That's how you use it. And then this here is the class overdraft account extends bank account. You can have checking account, savings account, right? Or you can have savings account with overdraft and checking account without overdraft. So you can have bank account, and then subclass of that is savings account, checking account, and then those now can have savings account with overdraft, checking account with overdraft. So you can design how you see fit in your situation. In this one, they feel overdraft account is the more sensible first child. And what is extra in this? The overdraft limit. The constructor takes account, name, and the limit, and it uses what? Super. It creates an account. It creates a bank account with the account number and the name, and then it gives a value to limit. So this constructor of the child class uses the parent constructor. That's how we did it really square. Remember? You see why I need to pay attention and continue reviewing so that we build on what we did before. Any questions? What? Which one?
From public class,
It extends what?
Bank account.
Right. Go ahead.
And after that, okay, so basically what I put is saying is that it takes a bank account and it extends it to overdraft account. As what you said, so
Yeah.
bank account, there are different types of accounts.
So bank account is the parent class and the child class is overdraft, which inherits everything that the parent class has.
Which
See, when you say it now, it plays up in your head more than if I say it.
And after the overdraft account, it's seeing those parameters. The
Right.
account number, the string name, and so on.
And it uses these two to create the bank account and add a limit.
Yeah. So since he uses name and account number, that requires a super.
It's super because it extends, this one extends the parent class. So super means that we're using the parent class, we're constructing the parent's class. So we created our bank account and added a overdraft limit.
Okay.
So we talked about method overriding and we have spoken about overloading. Right? Overriding comes into play when we do it inheritance, when the child has the same behavior but differently. What do I mean by that? Same behavior but differently. Right? You're doing the same thing your parent did, but you're doing it in your own way. So when you were small, your parent might have taught you how to be. But as you got older doing it for yourself, you have your own routine. Right? Your parent might have tell you what, shampoo your hair, and then scrub your skin, put soap, something like that. And you might decide, you know what, I'm going to scrub my skin and put soap, and when I'm done that, then I'll put in shampoo and conditioner. Yeah? You're doing the same thing, you bathe it, but differently. So you are overriding how your parent did it. What does that look like in code? When you override a behavior, how is that behavior shown in a class? How do you implement behavior in a class? As a method. It looks like a function, right? So when you have, if you're not overriding it, you don't need to write it because you could just use it inherit right here. But if you are overriding it, means that you will have a method in the child class with the same name as what is in the parent, but the actual code is different. So when we say you have the same behavior, it means you have a method with the same name in the child class. But the code is different. Might be slightly different or totally different. That's the key. Yeah? Make a sandwich. That's a behavior your parent has. You will make a sandwich. And chances are you might make it exactly how they teach you. But you know what? Your father likes ketchup in your sandwich, you don't like ketchup in yours. So you leave out ketchup. See? Same behavior, but different. So you're slightly different, but you have to override it anyway because you don't want it exactly like it. Or it could be totally different. Your dad likes a sandwich with whole wheat bread. You don't like whole wheat bread at all. You use white bread. Right? And you put in this and that and the other, different from what he likes. Why? Because he will still eat hot dog and you ain't eating that because you have too much of nitrites, sorry. You don't want ham and whatnot using fresh milk. It's still a sandwich you make it. Still make a sandwich, but totally different behavior. The steps, the instructions are different. I know I might be oversimplifying, but I think I have to since all the remember that. Yeah. As a fancy way of saying useless. And I was trying not to call it useless today. But I did it without saying it. Right? Yes? That's what we call passive aggressive behavior. You know, like you have some aunts and uncles like that. Right? Nonetheless. To override a method, provide an implementation in the subclass. The method in the subclass must have the exact same signature as the method it is overriding. What does that mean? The same name and all the parameters in the argument list. Yeah? So here we have bank account, private string, owner's name, account number, float balance. So here we're doing a deposit. public void deposit, float and amount. If amount is greater than 0.0, balance is equal to balance plus an amount. Withdraw is the same thing, but we taking away the amount here. You're withdrawing. Balance and withdraw, withdraw and deposit, same operation except the direction of the money is the direction that changes. Right? And then you have this method, public float get balance, just return balance. So these are the basic steps in bank account. How can we override that? With overdraft account, we will override, withdraw. Everything else is the same. But withdraw now, what will be different is you can here where you can take out money. Before you take out money, they have to check to make sure that it's greater than 0. Right? This really is not correct if amount is greater than 0. That's not correct. Right? Will this account allow overdraft? Yes or no?
No.
It's supposed to be no, right?
Yeah.
Right? But look at what happens. If you want to withdraw $1,000, yeah, you have to make sure that balance is greater than an amount. Right? The amount you're trying to withdraw must be greater than 0, and the balance must be greater than that amount. So it will not allow you to withdraw more than you have in the bank. That's what these two conditions are for. If you have an overdraft, you can withdraw the amount you want once it's less than your limit. Right? Yeah? Does this limit the amount it can be in overdraft? You see, when you have the overdraft account, you have an overdraft limit, right? Does this account take into consideration that overdraft limit? It says yes, right? But this is once the limit is greater than the amount. But if your overdraft limit is 35,000, but you take $25,000 before your overdraft, and now you want to go and borrow 20,000, will it let you? You want to take out 20,000, will it let you?
No.
Like what, the limit is still $35,000.
It's still.
Because there's no way when you do a withdrawal, it doesn't update that limit.
Oh, yeah.
Right? So the limit should be updated somewhere in the account every time you do a withdrawal, right? This overdraft limit should change. Or it should have keep a chart count on how much you have overdraft somewhere in the account. Right? But those are little things to work out. Right? The point is you have to understand how these code works. Inheritance defines a kind of relationship. Sorry, I was supposed to reply here to the Zilatech Vidish. We are face to face this evening, right?
Yeah.
I don't think we have. No, we don't have. So inheritance defines a kind of relationship because An overdraft account is a kind of bank account. Remember we said a square is a kind of rectangle. A square is a special rectangle. Right? An overdraft account is a special bank account. Because of this relationship, programmers can substitute object references. A superclass reference can refer to an instance of the superclass or an instance of any class which inherits from the superclass. Anybody understand what I just said? Not really, eh? What that means is you can refer or you can reference a child object with a parent variable or a child variable. So we can reference a square object with a rectangle variable or a square variable. If we reference a square variable, a square object with a rectangle variable, we are treating the square like a rectangle. That's when we say we treat the child like a parent. So when we reference, right, when we use a superclass reference to refer to an instance of the inherited class, that means the subclass, we are treating the subclass like the superclass, which is okay, but we cannot do the reverse. Right? We cannot reference a superclass object with a child class variable. So here, we create a new bank account, which is of type bank account, and here we create a new overdraft account, right? But we are going to reference this overdraft account with a bank account variable, right? Remember, bank account could be rectangle, and overdraft account could be square. So we can create a square object and reference it with a rectangle variable. Treat, that means you treated the child like a parent. Perfectly fine. But remember, when we treated the child like a parent, we can only ask that child's object to do what the parent object could do. Methods and behavior that are in the parent class. And this is where polymorphism comes in. In the previous slide, the two variables are defined to have the same type at compile time, right? However, the types of objects they are referring to at runtime are different. Runtime means what? When we actually create the object, we created one with a bank account constructor and the other with an overdraft account constructor. But this here is saying they are of the same type. Yeah? So, what we're reading here now is helping us understand the theory, the fundamental theory of this stuff, and it's going to help you to understand the jargon, the language, runtime and compile time and so on. Compile time is when you are building. Yes? When you build, when you compile. Now, what happens when the withdraw method is invoked on each object? An account refers to an instance of bank account. Therefore, the withdraw method defined in bank account is invoked. Account 1 refers to an instance of overdraft account. Therefore, the withdraw method defined in overdraft account is invoked. And the thing is, the overdraft account in this class is invoked even though you're using the parent class, because the parent class has a method called withdraw with the same signature. So withdraw is, in the child class, is overriding withdraw in the parent class. So if you're using a parent variable, you can get this behavior. Polymorphism is this. The method being run, invoked an object is determined at runtime and is based on the type of object receiving the message. So at runtime it can have a different form. Final methods and final classes. What does final mean? What does final mean? Huh? It what? End. Okay. So if I declare, if I do this, what does that mean?
75 is the final integer.
Right. And if I say, I come right after that and I do some code, whatever, and then I say m is equal to 60, and I run more code, what is going to happen?
It'll just
You get an error value.
because 75 is constant.
Because this 75 here, this is saying that m is constant, that once you initialize it, you cannot come and change the value, so this is not being allowed. So final is like saying a variable is constant. It's going to be held constant. That's an oxymoron there, a constant variable. Right? It's actually a variable held constant. You know when you did science in primary school? You know, used to do a constant variable. It's a variable that is held constant. So it's kept at 75. So if you have a method that is final, what does that mean? What do we mean that a method is final?
That variable is the constant.
What does that mean?
So it can modify after you
You can't modify it in a way.
after you
In the subclasses, you can't modify it in subclasses. So if you have a new class inheriting from this class, any methods that are final cannot be overridden in the child class. That makes sense? So the child classes will always have to do that behavior that way, and you can't change it.
Exactly the same.
Exactly the same, because whatever code is there, that's it. You can't override it. Now why would you do that? And consistency. If the business says, this is how we're going to do things no matter what, this is how it has to be done. Right? No matter what child class you have, this must always be there. Right? And that is the in business, you're implementing the rules of a business. And what would it mean when we say a class is final?
That class has to be constant.
What does that mean?
So you can change.
What does that mean?
That every time this class is called, it has to be done this way, or it can only go this way.
See, if you tell a constant, if you use final and say constant in the exam, you ain't getting nothing right. You have to tell me exactly what you mean. Right? When we say a class is final, it means that it cannot have subclasses. Those classes can't have any children. Nothing can inherit from them. It is full stop. And in business, there might be certain situations where you just can't have a subclass coming over that. Okay? Yeah? So, methods can be qualified with the final modifier, means that they cannot be overridden. What does it mean they cannot be overridden? They cannot be rewritten differently in a child class. This can be useful for security purposes, to implement laws and governance and so on. You just put the word final in front of it. Classes can be qualified with the final modifier. That means the class cannot be extended. So you can't say this class extends so and so. It cannot inherit from that class. This can be used to improve performance because there can be no subclasses. That's CAN, there can be no subclasses. There will be no polymorphic overhead at runtime. No polymorphism involved, so the compiler doesn't have to do any extra work. The programmer doesn't have to do any work when the system is being run. So like public final class color. So here you can answer these questions. What is inheritance, superclass, subclass, right? What classes are at the top of the hierarchy in Java? What are the constructor issues surrounding inheritance, like when super must be called only the first line? Method overriding, polymorphism, how are they related? The behavior, same behavior but it can look different. What is a final method, what is a final class? I told you there was very little to learn new. If you learn plenty of things new in that slide, well, good for you, but that means you're in bad shape. Right? What we're supposed to be doing here is just putting things together. Agreed? Now, we're going to look at the same thing again, slightly differently, and it will bring up some additional concepts. So overloading, inheritance, object initialization, subtyping, overriding, hiding. Right? So what is new, we'll cover it. What was done before, that's fine. Overloading of methods and constructors. We know what overloading is, right? Agreed? Which overloaded method to invoke? Well, when it's time to run, they will see what is the signature. So when you call it, it will see the parameters in the argument list, and it's going to choose which one that matches. Right? So we'll write overloaded methods where we can have the same functionality but with different arguments. For example, sometimes you want to do something, but you want to do it with an integer. Another time with a double. So same method, same everything, but what you're taking in is different. Sometimes you might do the same thing with a string or a char. And there are many such that you use, like for example printf. That is an overloaded method. Yeah? Because you could printf with just a string, with a string and integer, string and double, many strings, many doubles, all kinds of things. Inheritance models D is a relationship. If class S extends class T, then all objects of S can act like an object of T. Only single inheritance is allowed among classes. All public and protected members of a superclass are accessible in the subclasses. See, they say public and protected. Those members that are private will not be accessible in the subclasses. Okay? Remember we said that private are accessed only by objects of that class. All protected members are also accessible within the same package, and we said package is implemented as the folder. Other classes in that same folder, and when you write it, you see the package that you put in it, and once it's the same, they will put it in the same folder and they can access each other while it's protected. Remember we talked about that earlier. If you don't remember that, sorry, that's on you. Constructors of subclasses can invoke a constructor of the superclass, but super must be the first statement. We said that earlier. If the super constructor call is missing, by default, the no-arg super is invoked implicitly. That is the constructor with no arguments in the list, what we call the default constructor. It can also invoke another constructor of the same class when we use the this. Remember the this? And again, it must be the same, the first statement. Examples of this call, look at it, this public point, and we call it this dot x means the x up here is equal to the x that's this one. So So it differentiates between the xk and the xk. If you don't put this, the machine is going to be confused. Which one you're talking about? This is the default constructor. This default constructor is the no argument constructor. See, there's nothing in between our brackets. So when they come and they use these words to somebody who's reading this for the first time, or you don't have the benefit of a lecturer, it's difficult to follow what they mean. And we talk about super. So this one they give me examples using a point, the concept of a point. A point is tangible or intangible? It's intangible, it's done in relative to position and so on. If no constructor is defined, the following form of the no-arg default constructor is automatically generated by the compiler. Okay? What would be the use of the default constructor? It just constructs an object of the parent class. Rules: superclass first and field initialization first. Instance variable initializer versus instance initializer. So that's a little bit there. You don't have to worry about that too much. But the point is here. There's the class, there's the constructor with the same name. You create it, you initialize an instance, and it is referenced by the variable x. Okay? So when you have parent and child, now remember S extends T. T is the parent class. Right? So it shows you the order of how these things happen. You don't need to worry about that too much until they could internalize these steps. If I try to explain this, I'll frustrate myself and it will do nothing to you. But subtyping is the parent and child, right? So we have primitive types, notice with all the lowercase letters, right? So we'll have classes, objects, string, etc. And interfaces. We haven't done interfaces yet. And then we have arrays. Okay? So static and dynamic typing. Static typing is strongly typed languages. Everything, when you're going to declare variables and so on, you must say it's typed so the machine can put aside memory and so on. In languages that are untyped, the type can be worked out after whilst the program is running. That is dynamic typing. Java is strongly typed. C is strongly typed. Those that use artificial intelligence like Prolog and some of those others, those are dynamic typing. They get typed whilst the program is running. MATLAB and things that do those things. What's subtyping? So when you create a subtype, you inherit. You get the hierarchy, right? We can also subtype interfaces and things. We'll do that later. Substitution property. A value of a subtype can appear where a value of its supertype is expected. What does that mean, anybody? Example in arguments, results, receivers, and assignment. A value of a subtype can appear where a value of its supertype is expected. Anybody knows what that means? Wherever you put in a parent class, you can put the child class. The supertype is the parent, and the child type is the subtype. So a value of a child can appear where a value of its parent is expected. So anywhere you're using a rectangle, you can use a square. It doesn't mean that anywhere you're using a square, you could put a rectangle. Right? So they give you examples and you could read that code if you want. Rules of polymorphic assignment. The type of expression at the right hand side of an assignment must be a subtype of the type of variable at the left hand side of the argument. So that simply means left side where we have rectangle, and the right side we could use square. Same thing. But the language here, they're all very scientific and accurate. That there is no ambiguity. But because of that, it makes it very difficult. The language is kind of tough. But it becomes easy when you use it over time. So there's no need for me to explain that way too much, except to know that that's what it means. There's the fancy way of saying that the child can be treated like a parent, but the parent cannot be treated like a child. You can reference a child object with a parent variable, but you cannot reference a parent object with a child variable. You will get some exercises in that. Don't worry about this. We know about overriding. I don't have to explain that to you. Example with S and T. Don't worry about dynamic dispatch. Right? You can read it, and if you understand it, fine. Perfect. How overriding differs from overloading? Again, that has to do with dynamic binding, runtime, and compile time, and so on. Don't worry about that now. Hiding is another story when the variables in the parent class is private and we want to have it in the child class, we can hide it and use it. Don't worry about that. That's not in the scope of this course. And one more. So don't worry about those. We're looking at inheritance. You can read it. So you are supposed to be reading that, right? All the people who are not on the screen and talking to one another and not paying attention. So they use an example here. The same way they use shape and circle is how we use rectangle and square. And the reasons for that extends. We used all these examples and discussed them. So here we have a hierarchy with three person, student, faculty. You see they're using term super here. First in the thing. So to have a student, you first create a person and then create the other variables. So they talk a little bit more about super and the default constructor, what it looks like in memory. Polymorphism. So you will read that it at that part of the course. We'll take a 10-minute break, yes.
Yes, that part we just opened up to that camera already.
We'll see. Employee, a particular class of employee, but we're not sure how we're going to pay them yet. We can have everything worked out and we can just have that salary part as abstract. So in other words, we will have the name of the method, but we will have no code for it whatsoever. Right? So let me just give you an example very quickly, and again that will make sense. So we can have an abstract class. All right. Oh, how are you doing, sir? Right. So I'm actually in class right now. So
Nothing em music.
yes, I can call it back right now. I'll finish up at 12, so around there, is that okay? We have somebody after lunch.
I just want to see Yai.
Okay.
I want to see more what I thought I knew.
Thank you. Let's not
Yeah,
go
well,
over
I
that.
wanted to estimate the new one because I think I tell she remember I told her both of them.
Okay.
Oh, probably.
So I didn't know who it was in case it was a student.
Chanel told her.
Turns out to be the concept from
Chanel.
Ministry of Health. Okay, so a class, if it's abstract, we say public abstract, public abstract class, wherever. Right? Now, what makes a class abstract is if there's some method in it that's abstract. Everything else could be fine, but some method could be abstract. So when a method is abstract, we say public abstract, whatever that method is. Okay? So it has the name, and then the brackets here we'll have whatever is the signature, whatever parameters we need. And then we put a semicolon. That means we have not defined any behavior for this yet, except the name. Okay? So this class, with everything that's going on and whatever, will be abstract. Now notice, I just put semicolon here. If you were to do this, and put that closing bracket here for it, it is no longer abstract. Because you have defined in this method, well, don't do anything. Just sit there and look quickly. Right? So, no brackets like that. It must have the semicolon there. That's what makes it abstract. There's no curly brackets, so there's no code in there. From the time you put that, then it's no longer abstract. Why would we have a class that is abstract? Let's call this class capital C. Why would we have that? Simply because we don't know how this is going to be implemented here, whatever this behavior is. Okay? And you cannot instantiate an abstract class. You cannot say new C whatever and use the constructor, it will not work. Okay? If it's abstract, it's not well defined, so they're not going to do it because they would not know how to reserve memory and so on for it. So what happens here is if you want to use that class C, you will have to come and define some public class D or whatever. Right? And in here, you will say public class D extends C. Okay? And then what's going to happen now inside here, you will do whatever you have to do, but you will must define this. So now you'll have public, whatever. Let's say this behavior is BEH. You will say public whatever, BEH, whatever, and put in whatever code must be in there. Then you can instantiate D. And you can have everything that is inside of C will be available here, plus we will now know how to do this. Okay? And if you have different ways of doing that, then you can have many different classes extending C. Right? Public class E extends C, public class F extends C. And they will all have a different way of doing this. Yeah? And it's no longer abstract. And again, this happens in business a lot, when you will have a particular way of doing whatever their product or behavior, method, whatever it is, and this can vary considerably. So every time you define a new class, you'll have to define how to do this behavior. That's what makes it abstract. So we will see here a bit of it, right? So an abstract class is a class in which one or more methods are declared but not defined. Since they have no definition and cannot be executed, they are called abstract methods, and they must have the keyword in it, abstract. Otherwise, Java is not going to compile that. And if a method is abstract, then the class must be abstract. That was all. Yeah? But we'll see how that shows up later on. We talked about the final keyword, we don't have to go through that again. Here's an abstract class example. Public abstract class animal, and the method or the behavior there is sound. Public abstract void sound. Because different animals, the kind of sound they make will depend on the kind of animal class you write. So we leave that abstract, and when you define the animal class to the child, what kind of animal it is, whether it's here I don't think they care whether it's mammal or reptile or whatever, because they all have different kinds of sounds that they make. Yes? And again, this may not be the best design, but it's to show you the concept. So you have public animal, it string a type, and type equal new string, and then the to string and what have you, right? And type is private. So, an abstract method cannot be private, since a private method cannot be inherited and therefore cannot be redefined in a subclass. That makes sense, right? So it has to be public. You cannot instantiate an object of an abstract class, but you can declare a variable of an abstract class type. With the new abstract version of the class animal, you can still write animal, the pet equals null. So the pet is of type animal. Make sense? Now, if you derive a class from an abstract base class, so we derive this class D from this base class, which is abstract, and don't define all the abstracts in the methods in the subclass, then the subclass will have to be abstract. So if any of the methods there are still abstract, this class has to be abstract. But since we defined it here, we don't have to be abstract. If a class is abstract, you must use the abstract keyword when you define it, even if it only inherits an abstract method from its superclass. So if the only thing you define it is that method, that's okay. Right? So here we have public abstract class E. So nothing in our thing there. And let's take a look at how this works. So this class A is there, and they have three abstract methods. Right? They have int x, y. Now, it doesn't say whether it's private or public or what. So what is it going to be here if it's not set? The default is protected. Right? So you have They wouldn't use private here because it's going to make it difficult if you have it, you can't inherit. You could inherit it, but you wouldn't be able to access it directly. Alright? I showed you that, I demonstrated that in one of our early classes. So, public abstract void sum, sub, and mul, whatever those things mean. Right? I'm thinking sum will mean to add it up, subtract it, take it away, and mul will multiply whatever by x. I don't know. So public void shows system out, hello, I am class E. So these three methods are abstract, and this makes it class abstract. We could come and say abstract class P extends E as long as it has a abstract method. See, although we defined sum and sub, we still didn't define mul. So the class must be abstract. Then class C extends class B because now we are implementing mul. It's not abstract because in class B, these were not abstract. So the hierarchy is A, B, C. Right? This is abstract with 3 methods. This is abstract with 1 method. And this will have then all 3 methods will be defined. Because 2 were defined here, this will define the last one. Yeah? Then we can have a variable x. Right? If we can instantiate something from C, we could use the new constructor with this one. Right? Then we could have x could be of type A, and it could point to any of these. Right? And so on. And here, C is in making this method mul concrete. So it's really putting out the x squared. And here, it has a method named hello I am class C. Right? So show will put out A, show 1 will put out B, and show 2 will output C. Alright? I would recommend that you go in your Java program and implement these 3 classes and run these codes. I could do it for you, but it's better if you do it for yourself. A good teacher would leave some things for you to do for yourself. Right? What kind of teacher will I be if I'm teaching you to ride bike and I hog in the bike and riding it all the time? And you don't ever get to ride it. But I keep demonstrating and say, do this and do that and do the next. You ever learn how to ride the bike? So this class now is your main class with the main method. And here class C is a new class. Here you are instantiating the class A, like how I had X there. Right? If we use A.show, it's going to call the method from the class A. A.sum is going to call the method from class B. And A.mul will do the method from class C. A.sub will also pull the method from class B. A.show1 will pull the method from class B, and A.show2 will pull the method from class C. Is that registering to you? Why not? What class is show written in? Which abstract class? How many classes do we have? A, B, C. And we have show 1, show 2. See it? They're not that difficult, you just have to put your mind to it. So show is in A, show 1 is in B, and show 2 is in C. I am not going to implement this for you now and show you how it works. That's too straightforward. Right? That shows how much respect I have for you. That I know you can do it. And if you can't do it, figure it out. You ought to be able to do it. Why? You're going to get it on assignments. Yes? So if I say this was the show method in class A, what was the output? I belong to class A.
Yeah, this is class.
This one says I belong to class B, and this one says I belong to class C. That's how difficult it is. Yeah? And these three, sum and sum, were defined in class B, and mul was defined in class C. But because A, right, A was instantiated of type C, all of everything is available here because it inherited it. Right? And so I'm demonstrating it here, and I'm deliberately not doing it here so you will do it. Even if I have to hold panel here. So you have class A, class B, class C. Right? This is abstract. This is abstract. This is not abstract. Right? This has what? Show and sub, mul, and R is it? Sub. These are all abstract. Right? This has show 1 and sub and sum defined. Mul is abstract. Show says I belong to class A. Show 1 says I belong to class B. C says C has show 2. Mul is defined. Right? Yeah? So if we come and we say this, A is of type class C, and we instantiate a new object in class C. A belongs to class C. So when we say A dot show, which method will run? This. If we say A dot sum, which one will run? This. A dot sum will run this, because this is where it was defined. None of those are here. This has only two methods, mul and show 2. Right? So when we come and we say A dot mul, this will run. When we say A dot show 1, this will run. And A dot show 2, this one will run. Okay? What will happen if I come and I say P is equal to new class B? What will I get?
They get show 1.
Anybody?
Yes.
So P is of type class B. It's equal to new class B. What will I get? Anybody? You have written off yourselves from this class. You are no longer trying to participate and internalize. That was sleeping since he come to class, which he has done for all the classes he has come. Right? Don't forget, don't feel I didn't notice, you know, I noticed all who was boozing. I noticed when them two of them talked for the first half of the class. Right? I know that one was on the phone, I know this one was concentrating on something else. I'm just telling you that you put in your own self at it. There were one or two on this side who was sitting around looking at me straight in the eye for 1 hour and they understand nothing I see. And I am sure you will not find another lecturer who makes this stuff easier than I do. So if you're working with me, I can't help you. And I'm not sure if there are many others who can. You know, when you go later on and they explain, the man didn't say that. I damn well said it, you didn't listen. You understand it when you were ready to pay attention because the exam is coming up. And that happened to your classes before, this is not the first time. Yeah? And period? Yeah, I know who was focusing more on the computer than on what I was doing. I don't know if anybody doing an assignment now to hand them later or tomorrow, I don't know. But I know who wasn't paying attention to what I was doing. Yeah? Don't forget I'm mapping the exams. Yeah? And if I have to explain a high failure rate, I will. Okay? This will not work. Why? Because class B is abstract and you cannot instantiate an abstract class. Tell me anything I didn't say in class before. And right here in front of you. Yeah? Don't forget, you are second year university students aspiring to be engineers. And not just engineers, by the way, which is not a simple word, computer engineers. You have to do better than that class. You have to. Trust me. Which is why I'm not doing that for you, because you wouldn't understand anything I say until you implement it yourself. But when you go and sit down to implement it, hey, I'm now installing a Java boy. I'm now installing NetBeans and I get in trouble. What are you do here? And if you're trying to do that the week before exam, that's it for you. And if you ain't do it yet, and I could look at the expression, and I could call names of people who ain't do it yet. Right? That's not on me, you know, guys. That's not on you. And if you go write letters and take, fix up. I teach in here 20 years now. Nobody will take you, I'm telling you. So, when we write a.show, it's going to look for it here. It's not going to find it. It's going to come up here. It's not there. It's going to go here and find it. Any method you look for in the code, it's going to look in the class, the constructed class that did it. And if it's not there, it's going to look upwards in the hierarchy, all the way up to what? Object. Because this inherits from there, even though we don't see that. Like the string and thing. Right? So what we're doing here is that you cannot instantiate an object in an abstract class. What we remember here is what we did in one of our first classes when we did hierarchy. It will keep looking until it finds it. And if it doesn't find it, it will throw an error method not found. Okay? And then it will run mul. It can run mul here. It can run these two. Right? We could also come and say P, or rather X, is of type class A, is equal to E. And this is polymorphism. Because we're going to treat an object belonging to class C as a parent object. Yes? And if I say now X dot show, what will you get? What will it say? Will it run? What would happen if I say X dot show 1? Or X dot sub? Or X dot mul? So these work. Which will work and will not work? Let's start with this one. X dot mul. Will that work? variable is A, but the object we pointed to is a class C object. Right? Will it work? How many people say yes, it will work? How many people say no, it will not work? How many people and no and didn't put up their hand at all? Yeah, there are but 3 of you, I saw. Right? The answer is yes, it will work. Because mass is in class A. Right? But to execute it, it's going to execute it from the class that it was created with. Yes? So this will run. What about sub? Will sub run? Huh? How many people say yes? How many people say no? How many people can put up their hand? Well, they can put up their hand for the last one. So this will work for the same reason that this work. It's defined in B. It's defined. Right? And why will it find it in B even though the variable is class A? Because the class that produced it is class C. So it will go
Of the hierarchy.
right? What about show 1? Well, show 1. Will this work? Show 1. Where is show 1 from? In class B. Right? What type of variable is X? And what type of object is A? Class C. So, knowing that now, will it work? We did a demonstration over the last 2 weeks. Well, not last week because we had graduation. But the 2 weeks prior to that, we did a demonstration where an object of type rectangle, if we call a variable of type rectangle, could only call methods that are in rectangle, not what is in square. Even though the object is a square object, if we treat it as a parent, we can only ask it to do what the parent could do. Remember that? I demonstrated that for you. I'm not making this up, I actually did it. The code is there. I can pull it up and show you. Alright? Because A is here, right? X is of type A, there's no show 1 method in class A. The only behavior you can get in class A is what were defined in class A. Why we could only get that behavior? Because X is of type class A, even though A is of type class C. So we're taking that class C object and referencing it as a class A variable with a class A variable. So that means we're taking the class C object and treating it like a class A. So the only behaviors you can get from it are class A behaviors, because this class A doesn't know anything about show 1. Right? Knowing all of that now, so this will not work. What about X dot show? So it will work. What about X dot show 2? Keep in mind, show 2 is in class C. X is class A is class C. Will we get, will show 2 run? Will this run? How many people say yes? How many people say no? Very good. Because I was going to want to know if all you're paying attention, because X is of class A, so the only behavior we can get is class A behavior, and show 2 is down here in C, it will not run. Okay? That's polymorphism for you. The class C object, A, here is being referenced as a class A variable, treated like a class C. Yeah? Similarly, you can come and do class B, right? And let's call it B is equal to A. And we'll have the same question. What will be available to this is the same object, you know? And we reference it through a class B variable. So now we're treating it as belonging to this class. And the only thing that is available to it will be sub, sum, mul, and show 1. So show 2 will not be available to it. What about show? Will show be available to it? How many people say yes? How many people say no? Right. It will be available to it because it's going to come here, right? And what is available here? It's in the parent class here. So it's going to look here for what it could get. And if it doesn't find it, it's go up here. You could go up and look for things, not down.
So,
Yes.
just to understand, once B equals to A, that's when it will look in B, then go C.
Because we now treated that class C object as a class B. Right?
Yeah.
Yes. So, and class B could have everything from B up. Yeah. So, although it's a class C object, when we reference it to that class B variable, we treated it like a class B. When we reference it to that class A variable, we treated it like class A. So then we can only go there up. Up. Remember, the higher you go, the more abstract you get, the less is available to it. So, and we say that's what we're going to get up there. This will give you the sum, the product, the sum, and then it's going to output from show 1 is class B. Here show is class A. Show 1 is class B, and show 2 is class C. So they show you how it will run. They didn't show you what cannot run, which is just as important. Okay, now is ten past 11. Here, oh by the way, sorry. So we did here today so far, we did what? Inheritance. So although we implemented inheritance before, today we look at some details and issues with inheritance. And we also looked at abstract classes. So we have 3 more sessions. So we did all of these things, classes, objects. We did arrays and strings, but we didn't do wrapper classes. We do abstract classes and interfaces, inheritance. So we have 3 more classes. We're going to do GUI techniques, association, aggregation, and composition. And we will do interfaces. So we'll do interfaces next week. Okay? So next week we'll do interfaces. and wrapper classes. The next day we will do GUI. Okay, and the last class we will do aggregation and stuff. That's like 5-minute things. We do association already, but we'll still talk about it. So, let's take a look now at your final exam, at a final exam, sorry, not necessarily yours. And I'll tell you about your next assignment one time, right? We did some of these already, we went through that. Here you have a class. You're a programmer at OBP Runners where they manufacture furniture and whatnot. You have a class, bookshelf with attributes and some methods. Okay? Update the class diagram to put in setters, getters, and to string method. You could just have to put it the correct names for these terms. That's like 3 marks. The following points were agreed upon a method. I'll give you them and you will read them and try to do them. You have to write a whole class for this one. Right? So down here, we will tell you where it was. Write a class called, well here you're writing a class called bookshelf. Where is it? See? Right? You have to write the whole class here. Oh, there was a correction to this one. Write the class bookshelf. Using your updated class diagram, write the bookshelf class in Java canonical form, omitting hash code, equal, and end interfaces. So you have to write the whole class with all the setters, the getters, the constructors, the string method, and whatever else we talked about. Right? And you can write that there. Then here you write bookshelf app, and with a function main that you could create objects and run the various methods and print out the information and what have you. You want to know how to do those things. We did that already. Here now, question 3, 4, and 5 are based on the following incomplete classes. Abstract class animal, and the methods are make sound and make babies. Those are abstract. Critter extends animal, and all was, and you know critter is an American word, right? And of course you know that's a derogative of creature. Right? And then you have blackthorn. It's another animal you've never heard of. It's quite mythical. I'm the only person who ever heard of it. And of course the methods are there. Then we come and ask you, we give you an app, right? And it's going to tell you with these things here now, you're going to come now and you're going to answer questions about those 3 related to it. State all classes used in this program. What is meant by the instantiation of a class? Write codes to show where instantiation takes place. Name 2 instances of objects that are actually instantiated in the program. Write 2 lines of code using the program where inheritance is used. What is the relationship between critter and blackthorn? What is polymorphism? So those things, little marks, right? Give an example where polymorphism is correctly used in the program. Its application. See, I'm not asking you to write code, but you want to show me you know about these terms. Right? Pulling it out of the codes. What is overriding in object-oriented programming? is overriding used in this program in the code given? If yes, give an example clearly showing where it is implemented in the package. Explain what is meant by overloading. Is overloading used? If yes, give an example. And sometimes it's no in one and yes in the other, or vice versa, or no in both, or yes in both. So you can't say if it's yes in this one, it's no in the other one. This question is based on the classes animal, critter, blackthorn, and wilder. Read the code carefully, etc. To help our colleague further state whether these lines will execute or not. If they will execute, state what is the expected output. If a line will not execute clearly explain why it will not execute. And sometimes I might add and how to fix it. Right? So this line, make babies, will it work? This one, and so on. So obviously now all the things we just talked about, you have to know about those things. Yes? You're not going to figure that out just so if you haven't done the work. Right? If you go and you implement that class on the slides, you'll get it out. You'll have no problems. And your assignment that I'm going to give you next will be one of these. One of these questions from our past paper. Where you'll actually have to do it. It may be abstract classes, or it may be regular inheritance, or it may be with interfaces. Instead of using an abstract class animal, they decided to use interface. And well, you won't be able to answer that until we do interfaces, which we will do next week. Right? And the rest goes straightforward. So you have to know about everything. Abstract classes, polymorphism, interfaces, inheritance, the works. You can't do object-oriented programming without knowing those things. Okay, this one is try-catch finally. Oh, we have to do that too. So some here we're going to put, well, maybe we might do try-catch finally next week.
And you use error handling
We could.
in files? Any of things possible?
And that this will have meaning to you at that point. And that is your exam. What is this error? Why does this error occur? How would you fix this error? And a whole bunch of people just get one big fat zero for this question. Seriously. Some people just leave it out, and some people talk abject stupidness. So, there we go. So let's fix this now. Liam? Yes. Shivana? G. Zachary? Kelden? Micah? Majid? Lishra? Therese? Nivedita? Jordan? Okay.